my family has been requesting that I make a strawberry kiwi apple salsa lately, and it's something we need. So I came to my trusty old vintage Mac that can't be unplugged from my desk, and I'm going to get the recipe. So I have here one from A Taste of Home, and what I'm gonna do is I'm gonna write the recipe down so that I can then take it over to the island where I can assemble the ingredients. This is very similar to how in the cell you would have a protein being assembled, but you have to get the recipe for whatever protein you're making from the nucleus. You don't take the whole Mac over there, you don't take the whole set of DNA over there, you only are gonna copy one recipe. So that's what I'm gonna do. So I'm taking a look here. First, I'm gonna need 2 apples. There you go. I'm gonna need strawberries. I need a kiwi chopped. I need 2 tablespoons of brown sugar. And I need 2 tablespoons of peppers. So I was just transcribing the recipe, just as messenger RNA would do that in a cell. You see, you have other RNAs creeping around. Maybe that one was just made by the nucleolus. So now I'm ready to take my transcribed ingredients, just like, again, messenger RNA transcribing a gene in the DNA, and I'm ready to go to the ribosome, which is going to be my kitchen island. And there I will then assemble my salsa. And here at the ribosome, we will be assembling the strawberry apple kiwi salsa. We have all of our essential ingredients here coded for with our messenger RNA. There's our recipe. And now I will call the transfer RNAs to bring me the essential ingredients. The first one, strawberries. Here comes my first transfer RNA.
Hello, and her first child.
Kiwi. Gotta link it together. Apples. There you go. We got it right. Apricot preserves. And the final ingredient, the juice and rind of 1 orange. And the transfer RNAs can move on to assemble other amino acids. Here we are at the ribosome. We are going to assemble these amino acids into one amazing protein. So the first ingredient is strawberries. We have them mixed with the apples. With that, we're then mixed with the peppers. And then finally, some of the shoots and lemon orange. When we mix all of this together, it makes a gorgeous apple kiwi strawberry salsa. Just like how amino acids get assembled together to make proteins in a cell. Let's enjoy the fruits of our translation labor. Yes. All right. We got some cinnamon sugar pita chips.
Ooh, I didn't even know it was cinnamon sugar.
All right, Olivia, what do you think?
I'm trying to get it all.
What do you think? 2 thumbs up? So a recipe that should be tried at home.
No.
All right, go protein synthesis. Except for 1 abstains. So did you figure it out? Yes, the missing ingredient was the brown sugar. I did leave this ingredient out. So now as a result, because we didn't have that one piece of ingredient, the salsa isn't going to be quite as sweet. Now this happens in regular cells too. Sometimes you have a mistake that occurs during transcription or translation where you don't have the right base copied or where you don't have the right ingredients put together. And this changes the shape of the protein. It changes how the protein functions. And these types of changes can lead to problems called genetic disorders, especially when we're talking about germ cells.
during the reproductive processes. So one example of this might be a disease called Tay-Sachs disorder. And Tay-Sachs, you have a one base mistake. And because of that, it completely changes the way the fats are made, and extra fat is deposited on the neurons. And this causes the death of the child by age 3 or 4. So when you have these mistakes occur, they could be tiny mistakes like in our salsa, just not quite as sweet, or it could be big mistakes like things like death. And these are the basis for a lot of the genetic disorders that we see because of these random mutations that can occur during, again, transcription or translation.